This example is asking us to differentiate. Differentiate means just find the derivative of this given equation, and then they always kind of throw this little with respect to x in, which is just telling us that x is the variable that we care about. So nothing special there, just some more directions. What we're looking at here, we have f of x equals the tangent of, remember that this stuff is inside the tangent function. That's the first thing to notice about this. A lot of the times people read this as multiplication going on here, sort of tangent times something. Remember that all your trig functions, it's always of something. These tangents don't exist without something inside them. So here we're being asked to find the derivative of the tangent of 3x squared minus 8x plus 5. What we're looking at in this situation is what I refer to as a special case derivative. So special case in my world just means it's one you have to have memorized. You're not going to guess the derivative on your own unless you just have it memorized. There's really no way of getting from the original equation to the derivative. So if we look at this right now, if f of x equals the tangent of x, then the derivative of tangent, we just have to have this memorized, is equal to the secant squared of x. And the one thing to realize when you're doing these special cases, and there's a lot of them here, and we'll go through all of them, is as soon as this changes to anything more than just your basic x, which is almost all the time, as soon as that is more than just a basic x inside there, it's a chain rule problem. And so a lot of these special cases that you're going to learn are really going to be chain rule problems almost all the time, because they're usually going to replace that basic x with something more than just an x. So as we go to address this problem, we can see real clearly, real quick, that we definitely have something more than just an x going on inside there. And because that is the case, we know that anytime we have something plugged into something else, something inside of something, that tells us that we need to follow the chain rule, right? We said that already. And my chain rule saying that I use, it goes d in times d out. So, again, my rules sometimes vary from your actual teacher's rules, but the key is just being able to apply the chain rule 100% of the time. And so for me, this little saying d in, d out helps me do a chain rule right every single time. You'll notice that I probably will do it in the opposite order than 99% of the teachers out there, but I'm here to tell you that if you do it d in times d out, the chain rule will be a heck of a lot easier on you. So trying to find our pieces right now, I need to identify my in piece. Well, whatever replaced that basic x in your standard trig function here, that's always going to be your inside piece. So when I look to solve this, I need to find the derivative of the in. So I need to find the derivative of 3x squared minus 8x plus 5. That, as I look at it, when I break this into bite-sized chunks, I'd say, well, now that's just a bunch of stuff being added and subtracted. And so what that tells me is I can now go ahead and apply my power rule. Remember that really everything flows back through the power rule, almost always. And the power rule just says bring the power down and then subtract 1 from the power. So following that rule here, bringing our power down, we get 2 times 3 gets us 6x, subtract 1 from the power gets us x to the first. Moving on to the next piece, negative 8x, there's an unwritten 1 on that x, remember, so I bring that 1 down. That gets me negative 8x, and then subtracting 1 from the power gets me x to the 0. And as you know, anything to the 0 power is always equal to 1, so we don't really need to write 8 times 1. And then the derivative of 5, the derivative of a constant, goes away. Now when you come to look at the outside here, the outside is when you're running into that trig function. So the outside is the tangent of all of that stuff. So when we want the derivative of the outside, we follow our special case. The derivative of tangent is secant squared, but you're always going to leave alone all the stuff on the inside that you already took the derivative of. So all that stuff just stays inside the derivative there. So the derivative of the outside is just taking the derivative of tangent, which is secant squared. And now that we've done both of those small little bite-sized math problems, we now have all the ingredients we need to follow our chain rule recipe. So to get our final answer for our derivative, f prime of x, we follow the chain rule recipe. It says go grab the derivative of the inside. So we go grab our dn, 6x minus 8. Multiply that by the derivative of the outside. So the derivative of the outside, the derivative of tangent is secant squared, and then you leave alone all the junk you already took the derivative of. And so here we have our dn times our d out. That's our final answer for our derivative. Get up and walk away. There's no simplification necessary. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.